Hi, this is Scott from Chem Talk, and today is a very special day because we are going to do one of my favorite all-time home chemistry experiments. We are going to make copper metal, elemental copper from copper sulfate and aluminum foil. And it's quite easy to do, and it's a great experiment to show anyone who's really interested in science and chemistry, and it's a very accessible experiment. I will say that copper sulfate is somewhat toxic, so this experiment should be done with adult supervision. Really, you just need to make sure that nobody eats or drinks the copper sulfate, and you don't want to scoop it up by hand or get it on your hands. What are we going to use in this reaction? We have some copper sulfate. Copper sulfate you can buy as root killer, at least in the United States. It's sold in a lot of different hardware stores. I think I got mine at Ace Hardware. You also need aluminum foil, and we have some aluminum foil here. You need water, and you need good old salt. And that's pretty much it. And for anyone that wants to try this experiment by themselves, as a general rule, you want to use 13 times as much copper sulfate as aluminum. So if you use a gram of aluminum foil, you want to use 13 grams copper sulfate. That gives you a slight excess of aluminum and at least 4 times as much water as copper sulfate. So aluminum foil is really interesting element. It's an alloy. It's a metal mixture made of 98.5% aluminum, 1% iron, and 0.5% silicon. At least that's for the Reynolds wrap that I used. So in this experiment, we're going to use 400 milligrams of distilled water, 50 grams of copper sulfate, and 4 grams of aluminum foil. So first thing I'm going to do is weigh out 50 grams copper sulfate. Doesn't need to be exact. 15, 20, 30. Okay, that's just about 50 grams. It's about 50 grams of copper sulfate. That is going to give us a really nice blue solution. And you know, copper sulfate can be quite hard to dissolve. It's notorious for taking a while to dissolve, which is why we're going to use the hot plate stirrer here. Just a magnetic stirrer, and I'm going to put in a Teflon magnetic stir bar. We don't have to heat it up. And 400 milliliters of distilled water will easily dissolve all of that. It'll just take a few minutes. The blue color that you see is due to a coordination complex that the copper-2 ion makes with water. It actually makes a coordination complex with 4 and 6 water molecules, and copper and many other transition metals make a wide range of coordination complexes with ions called ligands. And I think it's one of the most interesting parts of chemistry, and a lot of people have a huge chemistry hobby where all they do is try to explore that part of chemistry, coordination complexes. And by the way, the copper powder that we make today is going to be used in a wide variety of future experiments. We can react it with hydrochloric acid and acetic acid to make copper compounds. Those experiments will need a little bit of help from hydrogen peroxide to get them going, but there's some really, really great experiments that we're going to do with this. Now, this is going to take a few more minutes. I want to stir this to get it all dissolved. So I'm going to just jump ahead, and then we'll have a nice finished all dissolved solution of copper sulfate. And there we go. Let's turn that off. After just a few minutes, all the copper sulfate dissolved. And if you don't have a hot plate stirrer, you can stir it yourself and dissolve it. It just may take a few minutes. Copper sulfate is notorious for taking a long time to dissolve. So now let's add in our aluminum foil, and I should have 4 grams there. Yep, 4.00. Perfect. So I am going to carefully put this foil in. I want to make sure we get it all completely in the water, like that. Perfect. Now, I don't know if you can tell, but I can guarantee you there's really nothing happening. The aluminum is not reacting. And the reason the aluminum is not reacting is because the aluminum foil has a passive layer of aluminum oxide that forms. In fact, all aluminum does this, and it's a micro layer. It's probably 50 or 100 nanometers thick. You are never going to see it or be aware of it, but what it does is it prevents aluminum from showing its true reactivity. And if aluminum is able to show its true reactivity, it would actually release hydrogen from water. So what we're going to do is add some salt. You don't need much, just a little bit of salt. But what that does is the chloride ions, they act as a catalyst, but they're not really a catalyst. They're not speeding up the rate of reaction. What they're doing is I'm just going to mix this up a little bit. And I don't know if you can see, but there's already a good amount of copper forming on the aluminum foil. What it does is the chloride ions, and it's really not fully understood how this works, but it allows the copper ions to somehow bypass and penetrate that layer, that aluminum oxide layer, and react. And I'm going to zoom in a little bit so you guys can really see that there's already a good amount of copper forming on top of the aluminum. If you want to see how reactive aluminum actually is, what we do is in another experiment on the ChemTalk YouTube channel, we combine it with gallium into an alloy, and gallium penetrates the crystal structure of aluminum and allows it to react with water and produce hydrogen right before your eyes. It's really incredible. Now, there is a little bit of bubbling in here. There is a small amount of hydrogen being produced, and that is because as the copper ions penetrate the aluminum oxide passive layer and react with the aluminum, there's also some water getting in. And again, when water comes in contact with aluminum ions, it instantly creates hydrogen gas. Now, because aluminum, again, is a very reactive metal. Now, the amount of hydrogen we are producing is actually very small. The vast majority, I'd say 99% of the aluminum is reacting with the copper ions, not with the water. But there is a small amount, and that's why you see the gas. So you can already see the copper forming on a lot of the aluminum foil, and eventually all the aluminum is going to be converted to copper. Actually, we put in a slight excess of aluminum, so there should be a tiny drop of aluminum left. But this should be just enough aluminum to react with all the copper in the solution. Again, every aluminum ion is transferring 3 electrons over to the copper, and the copper is being converted to copper metal. So we're going to wait a little bit until this reaction goes to completion, and then we will take a look at our copper metal and filter it and see what we end up with. So this has been going on for about 10 minutes, and there's actually a decent amount of hydrogen gas that's been coming out. The conversion to copper has been happening quite rapidly. I'd say a good portion, most of the aluminum has been converted to copper just in 10 minutes. And the beaker is actually quite hot. This is quite an exothermic reaction. It's not going to cause the water to boil, but I would not want to be holding that beaker. It would be very, very hot in my hand. There were some large pieces of aluminum foil at the top that I had to push down, but as it converts to copper, it mostly sinks to the ground. So you see the aluminum foil at the top, and we're getting a nice amount of copper. There's some aluminum in there, but I really don't think this is going to take all that much longer. You can see that there's a really, really nice amount of copper forming, and it all is going to the bottom, and that is pure copper metal. It's such a nice red brown. It's such a beautiful element. And I've done this experiment many times. Normally the aluminum stays floating at the surface, and this time the aluminum seems to be not floating, so that's okay. But we're going to let this run for a few more minutes until all the aluminum is gone and the solution is clear, which means all the copper has been reacted with, which is what we really want. We want to convert all of the copper to ions in the solution to copper. Okay, so after another 5 or 10 minutes, I do not see any more aluminum in this. And I also don't see any blue color in the water. So that makes me think that I got the ratio of aluminum to copper exactly right for this experiment. I think that I had just the right amount of aluminum to react with the copper. Now, just to be sure, what I did was I put in a small piece of aluminum foil, and I'm looking to see if it has any copper forming on it. I'll dig that out in a minute, but I did not see any copper on that. So that makes me think that not only did this go to completion from the aluminum point of view, but also from the copper point of view. And yeah, it's still pretty hot, but it's going to cool down. So I'm going to let this cool down a little bit more, and then we can filter our copper metal and talk about what kind of yield we're expecting. So the reaction is complete. That last piece of aluminum foil only had a little bit of copper on it, and all I did was shake it around a little bit with this glass stirring rod, and the copper metal shook off the aluminum foil, and then it was very easy to drag that piece of foil out. So now we have only copper metal, and we have aluminum sulfate in solution, and we have a little bit of impurities. We have a small amount of iron in there, a small amount of elemental silicon, and we also have a very small amount of aluminum hydroxide that formed when the aluminum reacted with hydrogen, formed aluminum oxide. So now what we're going to do is filter this. So let's take this off and move our hot plate stirrer out of the way. And by the way, I never used the hot plate today. I only used the stirrer part of it. Now this copper at the bottom is actually, by the way, I'm using just a coffee filter and a jar. Gravity filtration works quite nice. Wait till that goes through. The copper metal, because it's going to be in powder form, it's very reactive. It's going to be great for reacting with vinegar. It's going to be great with reacting with hydrochloric acid. Both of those reactions need some hydrogen peroxide to help them along, but really nice reactions. And I also want to see how nitric acid works on copper powder versus, say, a copper penny. So I don't know if you can see in there that copper powder at the bottom. That copper powder is so heavy, it just, there we go. Look at that. You can see it. It's really nice, reddish brown. Let's see if we can see. It doesn't even want to come out. None of the copper came out. So what I'm going to do is I'm going to actually scoop this out and dry it, and then let's take a look at it. So I want you to notice that the blue color is gone. All the copper ions are gone. Just another look. This is a really great amount of copper we got. This solution is mostly aluminum sulfate, which we can crystallize this. I'm not sure why this is reddish brown. The other times I've done this experiment, the liquid is quite clear. It looks like there's a little bit of copper that may be so fine that it's just suspended, and it's going through the filter paper that's discoloring it. But that's mostly aluminum sulfate. So let's, I'm going to scoop this out and then we'll take a look at it. Okay, so what I did was I switched filter papers, because what was in the other filter paper, it was mostly fine black particles of iron and silicon. All of the copper had settled to the bottom, and I was able to really easily scoop it out using this white plastic spoon. I actually have a metal, this is my metal spatula and spoon. It's made of iron, and it turns out that my spoon reacts with all my favorite chemicals and elements like copper and iodine. So maybe it was not a great idea to get that spoon, but I'm just gonna rinse this a little bit to wash off any aluminum sulfate that's still on there, or sodium chloride. Remember, we added a little bit of salt in there just to allow the copper ions to break through that aluminum oxide pacification layer. And that should be pretty good. We're gonna end up with, this is my trusty bottle of distilled water. I could not live without this bottle. And I think that should do it. That should get all clean. So now let's let this settle in here for a minute, let the water drain out, and then we're gonna scoop it into a into a watch glass and admire it. I used a plastic spoon and I transferred the copper into this watch glass, and wow, it is so beautiful. It is such a gorgeous red brown. I feel like this is like an art exhibit. I just want to spin it around like that and just look at that. It's just amazing. We used about 50 grams of copper sulfate pentahydrate, which is 1/5 of a mole. The molar mass is about 250, so 50 over 250 is 1/5. So the atomic weight of copper is 63.55, so we should end up with about 12.7 grams of copper. That's our expected yield. I am going to weigh this, and after it dries a little bit, I just want to spin it one more time. I love doing that. This is just the most beautiful specimen of elemental copper I've made. I think our yield is going to be pretty good. Everyone, thank you so much for watching. Please like the video and subscribe if you learned something today. We're going to have a lot more great experiments, reactions, element showcases, and lab tips and equipment. You can visit our website at chemistrytalk.org for articles, or to donate or volunteer to our nonprofit organization, and you can read all about our mission to make chemistry fun and easy to learn, and removing the negative connotations associated with chemistry. So I hope to see you soon. This is Scott from Chem Talk, and thanks for watching our video on copper.